Okay, cool. So yeah, so I guess like the purpose of these hacking sessions is to go the whole process through, maybe uploading a data set or downloading a data set, training a machine learning model, and publishing it on the marketplace. Because it's not well known how to do this at the moment, and like only a handful of people have actually published algorithms using some of these new tools. So yeah, just going through the process for the first time, I think we'll learn a lot. And also we want to start to train people up on how to do this so that we can form teams and create like interesting applications of this technology. And so what we did last week was we kind of just kicked off, and after that looked at the Ocean marketplace. So how to publish a data set, how to publish an algorithm, and these sorts of things. And now I guess like the first thing that I want to kind of chat about is, what's a good first application that we can build. And I think last time we were leaning towards something like a generative art model. And the reason for this is that, there's not many AI algorithms being used in Web3. But something that's gone crazy at the moment is like NFTs. They're so popular, and even generative art NFTs as well. But the thing is that this generative art is generated off-chain, so not on the blockchain, and then people just put the output images on the blockchain as NFTs and sell them. But we want to explore what happens if we can put the algorithm on the blockchain as well. And what this means is that the algorithm will have a token. So if if an NFT enthusiast is interested, they might buy an NFT output image. But what they can also do in this case is they could buy the algorithm tokens, for example, maybe stake on the algorithm tokens, which means that they earn a yield every time the algorithm is run. And it just basically opens up more value for more people if we can put these algorithms on chain. And maybe even in the future, we could put the data sets on chain as well, which means that if an algorithm is used, maybe we could direct a flow of value back to the data set that the algorithm was trained on, for example. And so, yeah, so this generative art algorithm is probably like the most close machine learning model that could be used in the ecosystem. So that's why we thought it would be an interesting case. And so I spent some time like looking into different generative art algorithms, and there's two people here who actually have more experience than me. For example, with StyleGAN2. So I wonder if we could just do a quick, because I think some people missed this, Viktor, for example, how you used StyleGAN2 before, and then maybe Holly, we could like explore how you use StyleGAN2 in your previous use case. So maybe Viktor first.
Yeah, so I mean, in a sense, like I retrained StyleGAN using other face datasets. So I was focused on the creation of face samples from StyleGAN. And the main idea was that if you want to take the samples and further augment it to make like a large face dataset using only StyleGAN samples, like one important feature is the identity. So like if you need to validate that the samples that you're gonna further augment, they are unique in terms of their identity feature. So like you can train maybe a face recognition algorithm. So like there, like I had to retrain StyleGAN in like several public data set, and then create the method to basically validate and find the samples that are unique in terms of their identity.
Yeah. Maybe I should have mentioned first, so StyleGAN is a generative model that you can train on a data set of, and it can be any type of data set. It could be a face data set, for example. And maybe you saw in the news a while ago from NVIDIA, they create these like fake face images, and you might have seen a title like "This person doesn't actually exist. Can you believe it?" kind of thing. And so what they did there was they trained StyleGAN on a massive face data set, and then the models have this what's called a latent space. And what you can do is you can move around this latent space and see what sort of faces are there. You can almost like interpolate between the different samples that it was trained on, and then you get like, you know, combinations of different faces and features and all that sort of stuff. So yeah, like Victor said, he was trying to create a synthetic face dataset to, you know, train facial recognition algorithms, for example. And Holly, I don't know if you want to.
I would have.
Could ask?
Can I ask questions about this? I mean, how did it turn out in the end? Like, was the quality of these images really beneficial for the algorithm? I mean, probably you tested it then on real humans where you had annotated data, right? So I mean, in the end, but like just for my understanding, like, did this really help a lot to improve the algorithm?
So I mean, it wasn't to improve the algorithm. It was like, so you have StyleGAN, let's say, that can like output new face images, right? So one component is that you want to show that they are unique, first of all, when compared as well to the dataset that you use, because otherwise you couldn't use them because of GDPR and privacy regulations. So like the images produced from StyleGAN, I found that they are not related to the images used for training StyleGAN, which was important. And the second part was, let's say you generate 20,000 images, like faces. These, they say, like they are not related to one another, but some, because the latent space is not, let's say, infinite, like some they have, like they're very similar when you look at them. So like I created the way that you can select the images that, like, at the end of the day, like let's say you create 20,000, at the end you'll have you'll start reducing images that they are the same in terms of their identity, and at the end you will remain, let's say, with 10,000 samples that are unique in terms of their identity, and then you can take them further augment these samples and create a face data set that you can train a face recognition algorithm, for example.
So the task was not connected to actually training then the algorithm with the output of this. It was more like a study into how to do these identities. Okay.
Yeah.
Good. Thank you.
Just if you don't mind asking, Victor, how much flexibility? I haven't used StyleGAN, but I've used a lot of different architectures in neural network, and so I'm just looking at the StyleGAN architecture. So you have this adversarial game, right? So you've got one side, which is the feed-forward convolutional network of some form with multiple layers. And on the other side, you've got the noise inputs coming in through multiple sequences of renormalization, convolution, renormalization, so filtering that then feeds back and goes into an entropy criteria to compete, right? How much flexibility is there in designing the convolutional architecture that's on the that takes the images in the first instance? What's your experience with that? And how, you know, what would be, how many layers, the depth of the layers you think is sensible?
Like in terms of changing it, or in terms of,
yeah, so like the baseline one that you just fine tune, right? That's the default. But I'm wondering, have you found any need to modify that in any way for certain applications? Or
well, I didn't really study that, so I don't know in terms of that. But like I think as they go, they introduced more and more layers. Like this kind of starts before it's called progressive GAN, and I think now, like the StyleGAN2, they have StyleGAN3. So
they keep adding more layers. And so the question that I have with this is that when you train those layers, you're usually using some kind of stochastic gradient descent, and the SGD that you apply can have a learning rate which differs per layer, because the amount of fine tuning you need and the amount of images you need to fine tune could get very expensive if you try to do all of the SGD on every layer the same learning rate. So I guess I'm just wondering about those kind of practical things in terms of estimation of the coefficients that go in these models. And if that's not the focus, that's also fine. I just wonder.
No. Like at least that wasn't my focus. I wouldn't know, like, to give you a precise answer. So
okay, something maybe I can have a look into. Just be interesting from the methodology point of view as to, because obviously that has a big compute cost. And the reason I'm asking is that if you then issue a token on one of these architectures, and then you change the architecture, you might wonder how much it might cost to recompute the output.
I think, like, when I retrained it, like it was the StyleGAN1, and I did it in 2 GPUs. I think to have some decent output, it took like 20+ days. Like I think in the repository there in the StyleGAN, they say that like how much time will it take to train based on how many GPUs. Yeah, so like it is expensive to retrain it from scratch at least.
Okay, yeah, thanks.
I think most research focuses on like with the GAN, you have a generator which generates the image and then a discriminator that tries to tell if it's real or fake. And I think most research focuses on the discriminator, I would say. And then the generator architecture is like, people change it less, I suppose. I don't know if that's right, Viktor, do you think?
Yeah, I'd say it's a combination.
Okay.
It's a combination of both, yeah.
I've seen that the group in Oxford, for instance, they've been using shallow Gaussian process networks to replace some of the deep layers of these of this component that's not the noise adversary. And so that's why I was interested in this, to see if you could get away with a stronger structure but less parameters. Yeah. So interesting.
Great. Holly.
Yeah, hi. So can you guys hear me all right?
Yeah.
Okay. So so my first project with StyleGAN2 was training 1 million images on silent films, and that was a StyleGAN2 model. And let's see, we trained from scratch, so we didn't do any fine tuning, and just used the standard, number of layers and everything, and ended up using GANSpace, GANSPACE, and that's basically the way of determining features. It'll kind of come up with different paths through the latent space and kind of show you, like in the case of faces, there will be a path where you add glasses or you make the person older, those sorts of things. So that was a project I had done for Google, Artist and Machine Intelligence project, and that we used 8 GPUs on that to train it. It took about 20 days or so to get any good results. And then my most recent project was 190,000 satellite images that I trained for Planet Artist in Residence. That's a Planet is they collect satellite imagery on a daily basis. And let's see. Yeah, I use GANSpace on that, and that's kind of where I generated some of these images. It was interesting to have the scientists look at it from Planet, and they could see that, it was strange to them because it looked right, but the geomorphology, where the Earth underneath didn't quite fit with the actual image that was being generated. So there was some oddity to that, and I trained it at home on my 24 gigabyte GPU, and that took about 27 days to train. So, and that's about all I have. So.
Yeah, I find it fascinating that these models take so much time, So maybe here at some point we could try to do more transfer learning than training from scratch. If it's like a blockchain based for Ocean, maybe if you reuse the trunks and then just train the layers on top of it, maybe that would be an interesting experiment, to see how much you can do with that, because just training everything from scratch seems to be very expensive, and I don't know if this is something that you really want to experiment too much with it. If you then have, I don't know, like 30 days of GPU time from AWS, you're probably looking at $20,000 or something. I don't know if people are willing to spend that, on the Ocean marketplace just to try something out. That's maybe if we could find for a first experiment something that people could transfer, learn, and then really be able to influence this a bit, then this would be probably something people would also like to experiment with. Because just generating the art is one thing, but like redefining the generator and publishing that again, okay, it's one level higher, but I think that would also be interesting for people. They could influence what the output is, because then they could create their own NFT series, like in an easy way. So at the moment, there's always these 10,000 NFTs for some kind of a purpose, and they mostly do them by hand. But if you could kind of find a way how people could do something creative by launching new algorithms that are generating those, then I think that would be also interesting. Yeah,
the 20 days was something I hadn't considered. I thought it might be like a few days, but 20 is a significant amount.
That's why I was asking in one of the chats about Robin's the size of the number of pixels, because I think this will also be dominated by how rich the input data set is. And you notice that a lot of the NFT art is very low pixel count. And so training on small pixel counts is extremely fast, right? And you can get away with really simple loss functions for the training algorithm, so it converges quickly. So the SGD doesn't take a lot of time, even if you have a lot of layers in the architecture. And fine tuning is usually pretty good as well. So I guess it just comes down to what degree of resolution you also might want to have in the art that's created. And I think that a lot of the NFT art is fairly low resolution, unless you go to things like Fidenza or Art Blocks, where it's a different story, or Pack. You know, some of these pieces are extremely high resolution, but they're not created in, they're just done in a static way, right? So it wouldn't, but they're rendered and resolved, and they rotate really nicely, as if it's almost like they're using like what is it, D3 Java to make them smooth. So there's a question there about what resolution we want to come to, I think, as well, as part of this question. Yeah. Even in the transfer setting.
That's an interesting idea too. Is like, so these two models that I trained were at 1024, but you know, and then I upscaled them. They have very interesting super resolution models right now. So you know, like say if we did a you know, a face generation at 512, but then we had a super resolution model that's trained on faces that could then upscale. You know, if we wanted to have another, you know, an interesting, we could also do something along those lines too. So we could train up a StyleGAN2 model fairly quickly, like you say, on smaller images, and then use a super resolution model to upscale it. But again, that would mean training too, maybe, and fine tuning the super resolution model. So, but anyway, just a thought.
I think that's a good idea.
I have some experience with super resolution as well, so that could come in handy. Yeah, so like, I guess my thought process as we were going through StyleGAN2, maybe I'll just share my screen quickly, just to like look at the data sets and stuff that they trained StyleGAN2 on. Can you see my screen? Cool. Yes, so this is the StyleGAN repo. It's in PyTorch, and I think they have a TensorFlow version as well. So like some of the data sets that you can train on out of the box, so the Flickr Faces HQ, which I think NVIDIA created. It's just a data set of images of faces. This one is interesting. It's like paintings of faces, which is kind of cool. This one is animals, so like African animals. And Cypher 10 is just like the like low res object data set, one of the early ones. LSUN, I looked into it. I think it's just like different, like one of them is a church, one of them is like a living room, just locations. And this one is like a breast cancer data set, which is like quite a colorful one with the pinks and purples and stuff. I guess it's like under a microscope or something. And so like what's interesting is that like one of the like things that I thought would be interesting is to use some of DataUnion's image data sets that they've been collecting. So for those who don't know, DataUnion is like they have a web app, which is where they can crowdsource images from people and like reward them in shares of that data set for images that they contribute. And so they have like a few different bounties. One of them is faces and people, because like Robin said, they want to create an anonymization algorithm. And another one was a litter. This was like a litter bounty. So Robin, correct me if I'm wrong, I think people were taking pictures of like litter on the beach for some robot that was going to detect litter.
A friend of mine has a robot startup, and there they are trying to they built a robot, and the robot can detect cigarette butts, and then he has a small gripper, and it goes in the sand, and then he just takes the cigarette butts away. The idea was here like to support him by collecting more data, because they don't have much, and this is a cool use case.
And so like that was my initial idea. but based on the resolution thing, that might change it. But I'll just show you what the data set looks like anyway. So like we were thinking, we could just use a public data set to start rather than this crowdsourced litter data set. And this one is called TACO data set, and it has lots of images of litter. So I don't know, you could train StyleGAN2 on some litter, a litter data set, and then explore the latent space to see if we could create some interesting art. And I don't know, raise awareness about littering or something like that. So that was my first idea. The other thing that's interesting, I just wanted to show the DataUnion app. So, sorry, wrong one. So Robin, maybe like you can talk about this as well, but
sure, I can. That's no problem. I mean, this is like the website where we collect data. I mean, you sign in here with the MetaMask with the wallet. We also have a mobile version, and if you are connected, then basically you can start validating. You can either validate what other people added, or you upload your own images, and then you add text to it. So you basically you start to create a data set, and then other people see what you added, and then they either validate or upload or download what you added. And there's also the opportunity to put bounding boxes in the images. So basically, this gives an opportunity that the crowdsourced crowd together can create such a computer vision data set. Yeah, so I mean, if you go to the top and for example go to start earning, and then verify. Okay. Yeah, upload means there you're uploading something, but here you can see like somebody uploaded this artwork, you know. So here you can also now, if there's this normal drop down, if you go there, you can also select here something else. So like Project BB Bounty, for example, this would be then about. So this might take a bit, but no, I hope it works. Yeah, so here now you can see that people uploaded something with cigarette butts on the beach, and if you go a little bit down. This is here, and here you can see like this tags. So that's what the people said about this image, you know. So like basically you could now add some more here. So like if you would write something, if you find something else that nobody else has found in the image, you can also add this, and then people can up and downvote this. So basically the crowd here together now creates these tags for the image, and basically then you know, okay, after a certain number of votes are in, we can then say, okay, we now know that this is for certain that this is in the image. And then you can start, for example, asking for the cigarette butts inside the image, where it is. So there we have this other feature. And like for different purposes, you can then start asking the crowd to do that. And we are always giving the people for all of their contributions a share in the data set, because you think, okay, we want them to be a part of that, you know.
So this is for uploading and verifying data, and then this one here is for like choosing subsets of the data, which might be interesting for StyleGAN. So for example, we can look at the data sets, and there aren't too many litter here images.
Yeah, if you go Project BB here, the same as before, like the one that we looked at. In the top, yeah, just here, the name of the bounty, basically Project, here, okay. Project BB. And then if you go, so there you can see 62 images are already uploaded. And so then you can see here what the people uploaded. These are all like the thumbnails. So these are not the original images, but yeah. And basically here you can now also then create your own data set. So basically you can select images here and add them to it. So if you would, for example, click in the top, select all, Richard, select all, and then go down to the bottom right. Yeah, and then click the heart. I would click the heart, but okay. Then you can basically select your data set, and then you save them there. And basically now, if you save them, it adds all of them to it. And if you then click on it, yeah, so then you can see here, okay, this is now your selection. And right now we're working on a feature that basically you can then store this data set in our backend, basically the list that you have created, and then on the Ocean Marketplace you can then select it again in our next version of the marketplace, so that you can say, okay, now I apply an algorithm only to this selection of this large image data set. So basically this enables us, or like everybody who wants to work with it, to select out of the vast reach of all these images that we have here, a few thousand, and probably at some point millions of them, or billions at some point. then to select what they want. I mean, the selection mechanism, of course, also has to get better. Right now, you cannot do too much at the same time, but it could also, at some point, it will also enable very complex queries, like only give me these and these tags, or like only if there's bounding boxes or semantic segmentation. And then you can basically search for those and then later start to work with that. So that could then also, yeah. So that's the idea of the data portal.
So, yeah, so my thinking on the litter one was you could just like choose really colorful ones, you know, ones that might give you like really interesting art and stuff like that. And then, yeah, create a subset of the data and then train StyleGAN on that subset, for example, and then explore the latent space. But yeah, like I really liked the idea of doing a low res image. And for example, it would be really interesting if we could train StyleGAN on CryptoPunks, for example. For those who don't know, CryptoPunks is like a really old NFT art. How many pixels?
You could blend CryptoPunks with Perky Penguins and all the others. You come up with some hybrid animal punk.
I mean, you can also scale the images up and down, right? I mean, it's not like if you want to do, yeah, but I think CryptoPunks is 24 by 24 pixel. I mean, it was created 2017. Then it was for free, and now Visa bought one for $2 or $3 million. So, like, I mean, just to put it as their yeah. So
but
I mean, it's fascinating.
Apes and they have the zombies and all the rest of those on OpenSea. You can download the JPEG, right? Obviously, you couldn't just reproduce them and put them on.
You can farm OpenSea as much as you want, yes, and download everything. That's true. I mean, the server is often overloaded and not so fast, but okay, if you do a little bit sleeping between the loading and the fetching.
We've been scraping heaps of stuff from there just for valuation stuff, but it could be fun to have, because they're low res already and people are already familiar with them. So coming up with hybrids of these could be an interesting, fun exercise to learn. Yeah.
I think that would be really interesting. Yeah. And so I guess. Go ahead.
Oh, sorry, Richard. There's another one that may be of interest to Holly as well. Just I mentioned in the chat. I don't know if this is of interest, but there's for those who are interested in Star Trek, there's a Vulcan dataset put out by the Earth Data Collective. It's high resolution annual fossil fuel CO2 emissions, and it has particulate matter, SO2, CO2. So you get these maps of like all kinds of different colors on the map, and you can imagine blending those across the different types of pollutants and creating interesting images for that with some slogans about what's going to happen, doom and gloom. Yeah, it could be an interesting one as well.
Yeah, and what's really interesting is that like a lot of artists use their own data sets to train StyleGAN, and then probably like wouldn't share them because they've collected this data set and it's valuable to them. But if you can imagine we could share them privately, and imagine there's 100 different artists who all have their data sets collected, they're all private and safe, and then you could do amazing collaborations. Like people were saying, you could train on one type of artist data set with another one and combine them in StyleGAN, and everything is done without the data set like being made public. And so if we can start to build up this collection of data sets that work with StyleGAN, for example, whether that's like CryptoPunks and then some other NFT or something like that, or maybe you combine it with satellite images, I don't know. But you could start to introduce lots of really interesting experimentation with art, all within the same ecosystem.
Here's a question for you, Richard. That was what we were trying to do at Resilient ML, but in an NLP setting, just a thought. So there's the ownership of the data, which is the original images. There's the ownership of the algorithm, which generates the outputs. But I think that there's also an ownership of the features that are in the layers in between. And obviously, when you do transfer learning or when you do some fine tuning, it's using the features. It's not using the data anymore, right? So I think that the features on their own are another set of data that could be part of this whole discussion and monetized in the way that we're talking about. So I just sort of add to that, because obviously that saves you the 20 hours to generate. And if you're doing the transfer learning, it's really the features you're buying, not the data.
Yeah, this is really interesting. And the different stages that the data goes through, how we store that on Ocean is going to be a really interesting question as well. So for example, for the breast cancer images, for example, you probably want to store the raw data, and then what StyleGAN does in the code is they take random crops from those images, And so I think the data set only has 200 images, but they create a data set of like 2,000 images out of it or something like that. And so what do you do with these intermediate stages of the data on the data marketplace? Do you store them both as separate data assets? Or like, do you not want to do that because then you'd have two different liquidity pools and all this sort of stuff? I don't know if anyone has any thoughts.
The way we were thinking about it was to build a feature library set where intermediate feature sets that are defined in certain ways become their own data set, because different users will use different levels of this feature process, this feature extraction or transformation process. So any kind of equalize. So usually the challenge is that you have unequal balance in the samples in certain classes. And so that would be a set of data, and then balancing that data set into different ways, like with distortions or different. So when you take these images and you distort them, you create the snapshot of them, you create just to focus on the head. This is how you generate those extra samples usually, right? And that basically adds a larger data set, but it's usually some kind of distorted version of the original data set. And the question is, is that worth more than the original data set? Because you've done effort, right? You've made effort to get to that point. So this is what you're saying. It's how do you distinguish between that? It's an interesting question. I'm keen to see what people think about that. So
yeah, I mean, the way you would distort this is like also a program, right? I mean, so you're doing this. So my idea was like to introduce a new kind of system in the marketplace. So to enable people to do pipelines, basically that you can then take the scripts and then also publish them as a data set, as a data asset, and then people could say, okay, I want to do this step and then this step and then this step, and also make them configurable. So at the moment, this is not possible. That's what we also work on now, basically an extension for the marketplace. So like, because we have our own backend, and then the wallet can store something there and we can retrieve it when they start the job. So that's why we have now kind of superpowers for the ocean marketplace, which are not possible there. And this would be also something that we're thinking about, like publish your script. The script might transform these images, they can transform somebody else's images, but they can then choose how to combine this. And basically they will then pay for the different steps. Like they will buy each one time.
I think that's a really good idea. This is the kind of models that a lot of the early machine learning data pipelines had. I think there's one that was created by MIT and it became a big thing for time series analytics. I forget what it's called now, but it's widely used. And it had this exactly like this mechanistic way of connecting up the blocks, and you could sort of pay per block. But there's still a step in between, which is some people, there's an incentive not to just pay for the block every time, because you could have the feature already there. Someone else has paid for the block and they can sell it on. So there's still a secondary market for the outputs from what you paid for, which is.
So you could always then say, okay, if I have a block and the data set, I pay for doing this once, and now I can say, okay, I think this will be used too often. I publish this again. And then if your marketplace would be intelligent, if somebody selects the two things behind each other again, it will automatically recommend, hey, you do not want to have this one. Somebody else published exactly this result again. So now this is cheaper than doing both steps again. So you want to do this. Right. I mean, it's all traceable on the blockchain, what was used. And basically then you can, like people have this option, and the person who does it first, they can then say, I publish it. So it would probably be the person who either created this extra step first, or the person who discovered, okay, this is something interesting that you could combine.
Then what you have is like what you have in commodity markets, a hierarchy of refinement. So it's what you get like with soybeans. The people who grow the soybeans, they can also sell the soybeans to turn into soy meal or soy oil. But the soybeans, soy meal and soy oil are also secondary products that sell themselves on the futures markets. And so they're not independent of each other. And sometimes it's better to buy the soybean and refine it. And sometimes it's better just to buy the meal straight away. And it depends on the demand and supply dynamics that are coming from those different base commodities or refined commodities. And I think the same thing is basically happening here in the data discussion we're having now. It's very interesting to see how that can be, because you'll have, like what you have in those commodity markets, you have different market demand and supply dynamics. And so you'll have different volume in the trading. And so the pricing mechanism will be quite different when you look at something which is less liquid compared to something which is much more liquid. And I think that getting that right is a real challenge, but something worth to think about. Sounds like you're doing this already, Robin. Sounds very interesting.
Yeah, I mean, like, but the thing, what I wanted to add is like, because, in the end, like maybe if you then, if many people only work with the derivative and then the original data is not used anymore, it would be great. It would be kind of a citation mode, you know, like I used this before, so now I'm publishing this new thing as a new data set, but it has a data token too. So maybe I can then contribute something of this back to where I got my initial stuff from. And then if in the future, you know, that something trickles back, so like it's a citation because I used it. But I mean, if the marketplace already does it like this, you know, like then automatically it always gives something back, because otherwise it's an exploitative model, you know, like I don't need the original data anymore because I just use it once.
Here's an interesting question on that, Robin. In some sense, what you're really creating is a derivative contract on the underlying data token asset. Okay, so the secondary market is a derivative market, as you would in any financial market. And you know that the derivative market can't trade independently of the spot market, which is the original data token. You know, they cannot be decoupled. And so the wider use of the derivative markets still drives revenue or value for the underlying spot market. So I think even if it didn't trickle back explicitly, that mechanism will still be there, as you find in standard financial markets, I think. But, yeah.
I mean, with these digital artifacts, I think it might be a little bit different. You know, it could be that you train this model one time on a data set, and then this model is good enough, and then you sell this a lot of times, but maybe the data set is just not used anymore. So so I'm now actively trying to make a model where basically it always flows back, just to align the incentives, and then just to align that the data set will be expanded and enhanced. But yeah, maybe it could also work automatically, but I think this explicit connection will make it clearer that the algorithms in the end will probably be the ones that are going to use a lot. And yeah, I think that it's something that we are researching now also. Like, I mean, for us, this is like the basis of what we want to do, and we want to really motivate this, that the algorithm always gives back. Because yeah, if let's say you have a car detection algorithm that's running an automated car for automated driving, the data set costs a lot of money, but in the end, like the algorithm will be used millions of times, and like the data set only maybe 2,000 times for training. So like the data set was very expensive, so like somehow you have to refinance the data. But if you know, like but the algorithm person, I mean, they pay for it 2,000 times, it's all right, and then forever they can use it. So if it's then really connected, then somehow it makes much more sense to contribute to the data set. So that's what we want to incentivize with DataUnion also.
Yeah, it's really interesting. Yeah, and then there's also the idea of like version control for data. I think Jakob Absentia are looking at this. There's like different tools like Data Hub, like GitHub, but for data, and also like DataLad. And how can these tie in with it? You know, can you just save the data as a single data asset, but with a certain version of the data set or something like that? I think that would be really interesting too.
I mean, what we were doing was we were having a versioning where every month the data set would become redundant. So if you bought the token, you would need to use it within a certain time window. And so every week the data set is updated. So there's an incentive to keep buying the data set if you're really using it, because it grows rather than just holding it for a long time. I don't know if this is the most effective or efficient mechanism, but basically it incentivizes people to keep participating in the baseline data set, even if they're deriving extra features from it, from algorithms, for instance. So there's probably multiple mechanisms that could achieve this kind of behavior. And yeah. I guess it's hard to know which one is efficient most.
Yeah, without trying it out, which is what this is all about, I suppose. So, yeah, I'm just thinking. So, like, we're running up on time a bit, but so what I might do for next time is download the CryptoPunks and maybe publish them on the Ocean market. That'll be the raw data set, and then we'll have to process it into the format that is accepted by StyleGAN. And so maybe we can publish that as an algorithm, you know, on the Ocean marketplace as well, the code which converts the CryptoPunks into the format that's taken in by the StyleGAN2 model, for example. And then we can publish that process data set maybe on the Ocean marketplace as well. And then after that, it'll be about, we need to create a Docker image for the code to run. But I think first, I don't know, everyone thinks we should probably get it running on a local computer first before we start using it on the Ocean protocol. So create the Docker image, have it running on a local computer, and then at that point after that, we can figure out how to run it on the compute to data environment. And then at that point, that will be a proof of concept for, you know, training a StyleGAN model on a data set, everything done privately. And then that means that can be replicated in future for other data sets that are actually private, because obviously CryptoPunks isn't private at the moment. So there's no point in having it as a private data set. But of course, there will be some data sets that people do want to keep private and use to train things like StyleGAN.
The problem will be that you cannot run StyleGAN on the Ocean protocol marketplace, because the whole marketplace is an example, you know. So the compute backend that is connected to it by the Ocean provider is like a few CPUs and a little bit of RAM, but not too much. So I mean, we at DataUnion, we're working right now on creating our own Ocean provider, but then there will also be GPU resources in the backend. So like if we then make the StyleGAN Docker image, then I would propose that we publish it over the DataUnion Ocean provider, and then it will also have a GPU to run on. So like we are taking their V100 GPUs, and we have like some startup credits from AWS, so it is also not costing us the work. And then we could then basically set it up like this, and then nobody else has to invest any money. But yeah, we can do it over this. But I'm not sure if this will be finished next week. But maybe we can start locally. But yeah, maybe we can take already the StyleGAN, which is trained on faces, and then just try to adapt it with the CryptoPunks. Maybe we don't have to start train it from scratch. I don't know if we could then just take this and retune the softmax on top, or whatever layers there on top. Yeah, maybe that would be the easiest. But yeah, I think we should follow in this way, because I think these profile pictures, these PFPs, like this kind of face images or like characters or whatever you want, I think those are really a highly looked after asset. So yeah, if those would be generated by AI, I think there would also be people interested in really playing with that.
Yeah, that would be great, Robin. And yeah, just in case anyone missed the first session as well, the idea is that we would publish this algorithm on the marketplace and share ownership of the algorithm, everyone who contributed in the Ocean group, in the working group. And that means that if by some chance the algorithm became really popular, everyone will get royalties flowing back to them. And I think like what we're hoping is that this can be one of the first algorithms on the Ocean marketplace that gets used, because I think like there's probably, you know, maybe 20 algorithms on the Ocean marketplace at the moment, and none of them get used. And so if we can create a popular algorithm that is used to generate these like popular NFTs, then ours could be one of the first algorithms that gets like quite a lot of use on the Ocean market. And I think that would be really cool proof of concept.
Just a question for people. I'm not sure if there's an interest in this, but just raise it anyway. There's also a possibility to write a short conference paper for something like ICML or Neural IPS, because it is pretty innovative to, as you say, it's the first time these things are done in the Web3 space, and it might be worth to raise attention. It's not a paper that's technical, but it's more an application paper. It could be worth to think about if people are interested in that. Happy to.
Yeah, for sure. I'd love to write one.
Let's get there first, and then we write the paper. I think it might need some iterations, because yeah, this is all brand new technology. So, I mean, but I really like the idea. I mean, this will raise awareness also to the science community, and I think especially for the science community, Ocean protocol in the long run would be a great addition. You know, like, because you can have large data sets and everybody in the world can work on the same one without having to always download them, and like you can share resources in the compute centers and so on. So yeah, I would be also interested in writing this paper.
Yeah, I love writing. So yeah, I'll definitely, we should definitely come back to that for sure. So yeah, another hacking session without any hacking yet, but I guess we're like setting up the problem, and at some points we'll dive into the code. Once we have like a plan figured out, which I think we're starting to converge on. So hopefully next week, maybe I can hack on the Docker file and, you know, download the CryptoPunks, and I can show people how to write the Docker file for the Ocean protocol marketplace, and we can kind of run it locally. And then at some point after that, we'll show, like, we'll figure out how to, you know, do the compute environment. We're trying to figure out everything in parallel, I suppose. And then, yeah, we'll be able to run it in the cloud. So hopefully more hacking from next week.
Just a question, Richard, in terms of the code aspect, which all of us, I think, here want to get into. So how do you want to do that? So do you anticipate that, I saw that you were putting some agenda items for the discussion. Do you want to put those agenda items associated with sort of blocks of modules of code or modules of components that people can go away and prepare some small notebook and then introduce it? Or how do you see that happening?
Yeah, it would be good if we could work collaboratively. So
Trello board or like a GitHub account, like making an organization for Algovera, and like all of us can join, and then you can also have the code there. And I mean, GitHub also has these issues and everything, and like you can have a wiki. So maybe we could then also just make something for this, and everybody can start. You know, Richard, it's good that you want to work on all of this, but maybe somebody else has time, and then you can split the tasks, and then it becomes more of a collaborative effort. And if somebody else wants to also just run it, then yeah, I think that would be the first step, and then we can start all collaborating in there.
Great, yeah. I can set up a repo on the Algovera GitHub then. Like we can start to create a README for downloading the CryptoPunks, and first bit will be like writing the processing codes to the format that works with StyleGAN. So yeah, I really like that. We can start to create
just make some cards what you think is necessary, and then people can claim them, and then you can divide and conquer.
Perfect. Great. Yeah, we're starting to get somewhere. So yeah, really exciting. I'm really looking forward to diving in. And yeah, reach out. I'll create the GitHub repo and I'll send you all invites, and you can join, and we can start to like push some code and stuff. That'd be really cool.
Sounds like a lot of fun. Yeah. Great.
Fantastic. Great. Thanks, everyone.
Good to see you all. Thanks, guys.
Good to see you.
Soon.
Bye.
Bye-bye.